Okay, so next we're going to talk about the dimension of a subspace, which is the number of vectors in a basis. So this tells us the smallest number of vectors that we need to build up all of our vectors in our set using linear combinations. Okay, this is a very helpful tool for writing down all possible subspaces in examples like R2 and R3. We'll be able to say these are the possible subspaces, and that's it. All right, so let's take a look. So in R2, there are going to be 3 kinds of subspaces. So every time we have subspaces, there's one which is the 0-dimensional subspace. Here we have just the 0 vector. Okay, and so if we were to draw this in R2, what does it look like? It's just, if we're just drawing the ends of the vectors, it's just the 0 vector. Okay, this satisfies the subspace properties, right? If you have just the 0 vector, you take linear combinations of the 0 vector, it's still the 0 vector. Next up, we have the 1-dimensional subspaces. Okay, so these are formed by a single their basis is going to be a single non-zero vector. So these guys are going to be the span of a vector v, where the vector v is not equal to 0. Okay, so what this is going to look like is we're in R2. Our subspace is going to contain some vector v. And it's going to be all linear combinations of this, so any scalar multiples. So if we think about where our scalar multiples are, what does this look like? This is a line through the origin. That contains the vector v. So the 1-dimensional subspaces in R2 are going to be all of the lines that go through the origin. Okay. Remember, we have to contain that 0 vector, and so lines that don't go through the origin will not be subspaces. And then there are 2-dimensional subspaces, right? If we think about all of the vectors that we can build with 2 linearly independent vectors in R2, well, that's everything, right? So for example, you might have as a basis 1, 0, and 0, 1. We can get to all vectors in R2 using this basis. And so the way that we would normally, if we were sketching this, I might say, okay, just everything here. It's all of R2. Okay, and these are our possibilities. Okay, so if we see anything that doesn't look like this in R2, then it is guaranteed to not be a subspace, because this is the full list. In R3, we're going to see 4 kinds of subspaces. We're going to see 0-dimensional subspaces, which contain just the 0 vector. We're going to see 1-dimensional subspaces, which are just going to be lines. that go through the origin. Let's pick a direction, got a line going through the origin. Pick a different direction just so it's a little bit easier to see. Okay, so these are lines through the origin. Containing V. We have two-dimensional subspaces. If V and W are linearly independent. Then they're going to form a plane that goes through the origin. We have just two directions that we can build everything with. Okay, so for example, we might see the plane. I'm just going to draw a little triangle in this plane. But for example, here, this is the plane based on the Z direction and the Y direction. So this would be the span of 0, 1, 0 and 0, 0, 1. Or the YZ plane. And then our fourth type of a subspace is just going to be everything. So the zero-dimensional subspace and the p-dimensional subspace are always going to be present, where it's everything or just the zero vector. Okay, so this is going to be all vectors in R3. Okay, and you can see here that if we look at the dimension, then it doesn't matter so much what space these vectors are living in. Within that subspace, the pictures look very similar. So, for example, if we have a one-dimensional subspace, if it's in R2 or R3, there's only one direction we can move in, and so this looks like a copy of R, right? We might as well be thinking about living in the space R. Similarly, if we look at two-dimensional subspaces, these are planes. There are only going to be two directions. We can build the whole thing with just two directions. And so whether we're living in R2 or a two-dimensional subspace in R3 or a two-dimensional subspace in R4, the picture within that subspace is going to look the same. Great. So in R4, we're going to see zero-dimensional subspaces, one-dimensional subspaces, two-dimensional subspaces, three-dimensional subspaces, and all of R4. So we'll see these three-dimensional subspaces as like copies of R3 living in R4. All right, very good.